So now we would like to move on to the next talk. So next talk is from Professor Downie about how to use the big data, especially in the context of the humanities and social science. And Professor Downie is going to talk about the cases from the HathiTrust Research Center.
That's it? Awesome. Hello, everyone. I'm Stephen Downie. I'm a professor at the University of Illinois School of Information Sciences, and it's very nice to be here with you live at the beautiful Kyushu University in Fukuoka, and of course online. Hello, online people. Very nice to have you join us today. I'm going to talk to you about my work, ongoing work with my colleagues at the HathiTrust Research Center. If you're not familiar with the HathiTrust, it's a large digital consortium that curates a lot of books. And I'll give you a little bit of history in a minute. People here know the HathiTrust? Anyone know the HathiTrust? No? Okay, just an interesting aside. Hathi is the Hindi word for elephant. That's why you will see the little elephant in the logo. And elephants are big, they live a long time, and they have great memories. And that's the reason that they chose Hathi as the name of the trust. And please, if you have any questions, feel free to email me or join me on Twitter. I like making new social media friends. Okay, this slide deck, some of you have seen some of the slides on this slide deck. It grows over time with my students and my colleagues. So I want to thank all the people that helped me make these slides over the years. This talk addresses the challenges that we have at the HathiTrust and how the HathiTrust Research Center can overcome some of the challenges in dealing with a very large collection of data. And another interesting side challenge, this data gives birth to new data. So it's growing because it exists, and I will explain this. Thank you very much, I appreciate that. I'll explain some of the reasons on how this data keeps growing. So what we're looking at is how do we manage the scale of the HathiTrust, and I'll talk about the scale in a minute. And then how do we take advantage of the scale? What does having a lot of data do for us? How do we facilitate research with this data, given the constraints of copyright law? And how better to enable work with non-English texts, that is, non-Latin texts, right-to-left texts, and languages like Japanese, Chinese. And then how do we curate a collection like this to make it more diverse, inclusive, and reflective of the actual world around us, especially the world as reflected in books, for example? And then how do we manage the data that is generated by using this data? And that will be my talk today. So the HathiTrust is a partnership of member libraries. There is one member library in Japan, and it's Keio University. A collective digital library is the largest ever assembled in the world. The University of Illinois Urbana-Champaign has been a member for a long time. And we have about 1 million of the books that come from the University of Illinois. It's the outcome of a very large-scale digitization process. It is considered the trusted repository. It is the archive of these books. So should these books be destroyed, we have at least one digital copy for the world to use going into the future. We also provide the HathiTrust provides special services for the blind, and collaboration services for libraries. And one service that became very famous in the United States, the Emergency Temporary Access Service during COVID-19, member libraries were gained access to the digitized books, even if they were in copyright. And that service was very widely acclaimed. And it also is the host of the HathiTrust Research Center, where I work. So this is a very big project. There are 17 million books in this collection. There are 8 million book titles, so some copies are duplicate, for example. There are 469,000 serial titles, so journals and so on. I love this number. This is my favorite number. There are 4.6 billion scanned pages in this collection. It sits on 791 terabytes of disk at the University of Michigan. That's where the collection is housed. If put edge to edge, the books would stretch for 209 kilometers, which is about 209 miles, about 300 kilometers. It would weigh 14,000 tons, which is many elephants. And about 7 million of the volumes are in public domain, which means the remaining 10 million are under copyright and can't be freely shared. But we have the data, and we're going to find a way to make use of that data. The HathiTrust comes from the Google Books project. So the Google Books project started in the early 2000s. A consortium of Google and libraries got together to do digitization. And how to describe it? The bargain, the deal was Google would come and do the scanning, and Google would take a copy of the data and do Google things. And a copy of the data would be given to the universities for their data management, and that's the HathiTrust collection. So that was the bargain that was made with Google. There was also a very famous lawsuit that the Authors Guild, the publishers, made against the Google, the HathiTrust, which came out in favor of what we did, in favor of the HathiTrust, in favor of Google Books. So that was good. So the digital library is only about 50% English, which I even find surprising, given that it is mostly American and some Canadian universities. It includes over 450 different languages. It spans from about the 15th century through to the 21st century, with the bulk of the books in the 20th century. 61% of the books are under copyright and cannot be freely shared. Wide range of genres. Think of these as photocopies of university libraries. So lots of science, lots of history, government documents, fiction, and so on. Not as much, but it is there. And of course, all the items are contributed by the member libraries. It's not perfect in any way, shape, or form. There are many scans where you can see a hand or a sandwich or car keys or torn pages, and these are some of the examples of some of the broken images. It's one of our projects to find these and correct them. And of course, the OCR is not perfect either. And that's another one of our projects to help identify the causes of OCR problems and to correct them. So the HathiTrust is not a universal digital library. It really is dependent on the libraries themselves that participate. So it reflects those universities. It reflects the University of Illinois, Harvard, Oxford, University of Michigan has many books in the collection, but it's oriented around what those libraries collected. So there's a shortage that we perceive in such things as fiction. And also, one of the other things is that it reflects the collection interests of different librarians at different times. So there's a shortage of African American texts, Native American texts, and so on. And that's one of our projects, is to identify these gaps. You can see there's the dates range on the different volumes. You will see spikes around 1900. That is because the catalog records sometimes are imprecise, and we'll just put 19XX as the date. And so you get this big cluster. Not all these books were published in 1900. They were published sometime in the 20th century. So it's another one of our challenges, is to determine the real dates of these publications. And you can see there, Chinese and Japanese, each consisting of about 8 to 9% of the collection. Our number 2 language is German, which makes a lot of sense if you think of science publication, and philosophy publications were very much German oriented up until the Second World War. And these are scientific university libraries that we're collecting. So very strong representation of German texts. There's the same information again in a different form, and you can see Chinese and Japanese off to the left-hand side of the graph. Okay, the HathiTrust Research Center is a collaboration between the University of Illinois, and I represent Illinois, and our colleagues at the Indiana University at Bloomington. Very pretty campus, much prettier than the University of Illinois. And we come together, we have lots of Zoom meetings, and our job is to provide computational analysis of the texts. We do something called non-consumptive research. And we help with collection building, data crunching, creation of new tools to use the collection, and also to figure out more about what's actually in the collection. Non-consumptive research is this branch of research that allows text mining of copyrighted material, but not the reading of it. So that's why it's called non-consumptive. It's also called distant reading. It's the computer that's doing the work, not a human. In this way, we stay within the boundaries of copyright law. So we are allowed to do computer analysis of copyrighted texts, but we can't read them or share them with people. So that is non-consumptive research. We're not consuming the books. So this is what I just said, right? Non-expressive use. It is at the heart of what we do. It complies with American copyright law. I'm not sure about Japanese copyright law. If there's a Japanese copyright lawyer in the room, I would like to know. And we do this through different mechanisms of access. We transform the data from copyright into non-copyright form, and I have an example of that. We have special computational services called data capsules, where people can run algorithms against the collection, and that is legal, and then we call that data capsules. And so we help researchers do machine learning and artificial intelligence against the collection, text extraction, textual analysis and information extraction, like named entity recognition, linguistic analyses, image analyses, OCR issues, correction, manipulation, indexing, and search, and so on. And there's some examples there at that URL if you're interested. So we provide some partial access to the open part of the data. On the controlled access, that's our use of the data capsules. We do catalog metadata is all the metadata that's found in the catalog records is very useful to researchers and is in high demand. And then we transform the data from a copyright format to a non-copyright format in our extracted features data set work. We build tools that sit on top of our data. One tool that you might have fun with is called the Bookworm, and the URL is right there. You can go there right now and play with it. It is a tool that counts the occurrences of words over time. And we added a new feature to it using the catalog records. We can facet the search against different aspects of the catalog record. So we can do different genres, different countries of publication, and so on. This example here is the use of the word Darwin. It's Darwin, Einstein, and Freud as found in the text over time. So you can see different patterns. It runs a bit slow, but it does work. We also do analyses of different subgenres. In one example, Professor Ted Underwood, English language fiction, and how words are associated with different characters. In this particular example, it's whether the character is a female character or a male character. And you can see that the female character uses the word heart differently than the male characters. And you can choose any word you want and see if there's a difference. And that work was done by Professor Ted Underwood. One of our services is called the Extracted Features Data Set. And this is another example, or an example, of us creating new data from our old data. And it's a data set derived from the entire corpus, even the in-copyright works. But because we've taken out the copyright aspects, it's open. You can download this data right now. It's open to the world. It's volume level, page level. So each individual page, we have data. And at the individual words on each page, what part of speech they are, for example. We publish it in JSON format, very standard format. Python likes to use JSON data. Students understand it. And it's copyright free, right? This is one of our sort of policies now, is that we make sure not to put restrictive licenses on our data. I think the data is actually CC attribution on the Creative Commons license. And I make this recommendation: make your data as open as possible. Don't worry about licenses. To make it open, CC 0 is probably the best. And there's the CC license right there. So the extracted features data set is 17 million volumes. We're a little bit behind the entire collection. 10 million in copyrighted works are represented, 6.5 million public domain works. 6.2 billion pages of data, 2.9 trillion tokens that people can use to build projects and do analyses and so on. And it's open to the world. It's about 0.5 terabyte compressed, and it's about 15 terabytes uncompressed. It's a big data set. And there's the DOI attributions and so on. And you can just go to the HathiTrust site or the HathiTrust Research Center site and download it as you need. There's an example, so you can see it, probably a bit small. You can see the JSON encoding, and over on the right-hand side, you can see each individual word and its count and other information about the page. Okay, we have other data sets that our data set has given birth to. We have word frequencies in English language literature, again, curated by Professor Ted Underwood from 1700 to 1922. And then we have geographic locations in English language literature by Professor Matthew Wilkins and his student. I believe that's his student, Gao Zhenran. And those are also available to take a look at. And that's the geographic locations is more along the idea of named entity extraction. We built a tool using our extracted features called Workset Builder. I'll talk about worksets in a minute. This allows us to find individual pages with given words. Also, because we have parts of speech, we can use the parts of speech information to distinguish between verbs and nouns and adjectives and uses of words to get in. And we've used it to help us discover problems with languages other than English. So we wrote a paper about Maori. I have a colleague in New Zealand that was interested. And there are Maori texts in the collection, but they're mislabeled. And we did some studies on how to find Maori texts in the collection. That's with my colleague, David Bainbridge, who works at the University of Waikato. A work set is basically a custom subset of the collection that is used not for reading, but for computation. So it's that subset that you take and put into your computer and crunch and make new data and new findings. That's a work set. We use that terminology deliberately because we also speak of collections, which are things that librarians put together or researchers put together more to read. So that's why we use this special language of work set. And even if the work set itself cannot be shared because it contains copyrighted information, we can share the pointers to that information so that reproducibility can happen in the absence of absolute data sharing. It's a hard problem that we're always dealing with. So one of the other tricks that we have to give access to this data, sensitive data, we cannot share it. Rather than us giving data to researchers, researchers come to us with their algorithms. They take their algorithms and they put them in a special kind of virtual machine called a data capsule. They run their data, their algorithm against their work set that they created. They create a work set. And then we look at the outputs. So after they've done running their analysis, if it looks like they're not just copying the data and running away with it, then we press a button and they get their answers delivered to them and they write their paper and they do whatever they want. So that's one of our mechanisms by which we do data capsules. It does not scale very well because a human each time needs to look at their results to make sure that they're not copying data. So it's a challenge for us to find an automated way to do this checking. So some of the work, how we deal with some of these challenges. We do a lot of machine learning, a lot of text analysis, and it's always a combination. It's a combination of technology, so AI, machine learning, NLP, and some kind of scholar, some kind of expert. And our approach is to bring the two of them together. So we were visiting here in Japan and we were asked at one point, how good is the collection for Japanese in the HathiTrust? And it's not really good. There are a lot of mistakes, and there are even mistakes in the cataloging. And we've applied some automated tools saying, oh, we'll find some more Japanese by using a natural language processing tool. It turns out that we get lots of errors, and those are some of the errors that we get. Just anything that kind of looks graphic, like kanji or hiragana, ends up being labeled Japanese when it's actually a picture of a tree or something else. We get some of that. Messy handwriting sometimes gets misidentified, and so on. You can see that there from the paper. And we published a little report on it at the Digital Humanities meeting in Tokyo last summer. We also have been asked by the HathiTrust people to identify what's on the first 20 pages of each book. Each book, regardless of copyright. So the first 20 pages of each of the 17 million books. The reason we were asked is that they would like to open up the first 20 pages, give the actual page images, because the thinking is you would get a table of contents, you would get the acknowledgements, maybe an introduction. The problem, the challenge, is many times in some books, there would be an additional picture or artwork that we might have copyright problems with. So we tried to build tools to identify what's on the very first pages of first 20 pages. And so we used CNNs, convolution neural networks, and recursive neural networks to see what we could find out about what was on the first 20 pages. And we published a report, and we published it at iConference in 2021. It turns out we can have a pretty good sense. We'd only get in trouble a little bit, so it worked out well. We also have been doing studies with the PhD students. This is with Min Zhang, who's now graduated and a teacher at the Indiana University, Purdue University in Indianapolis. Her whole thesis was looking at the effects of OCR errors on some of these fancy new transformer algorithms. And for the most part, they're pretty robust against OCR errors, which is good because the HathiTrust has a lot of OCR errors. So we can have some confidence for some of the transformers that the results are good. There's a couple of situations where it's not as good as it could be, but overall, it's pretty robust. And we've published in several places. You can Google it if you're interested in that work. So another place where we run into trouble is literatures that aren't science, but or written by people that aren't Newton or Einstein or famous scholars. So we got a grant from the Mellon Foundation, and we created a project called Squared, which is scholar-created work sets, curated, for analysis, reuse, and dissemination, or Squared. And this is a combination project where we're going to use tools to work with scholars to help them do digital humanities, data analysis, data science projects on specific interesting sub-collections of the bigger digital library. And those are the projects that we ended up working on. So we worked on Native American authored works. We looked at the Black Fantastic, which is African American Black science fiction, really fascinating stuff. And then period Pacific work sets for Latin American fiction. As you know, there's a very strong Latin American community in the United States. And then the National Negro Health Digital Project, looking at texts that have to deal with African American Black public health over the years. So some of the challenges include identifying whether we actually have it in the HathiTrust. Because the one thing that's a bit problematic about how the HathiTrust Digital Library comes about, it's not done thoughtfully, it's done automatically. The scanning teams would come in and take all the books off the shelf, just put them in a truck, take them to the scanning factory, scan them, and put them into the digital library. So if the book was not on the shelf that day, that book never got scanned. There's no scan of that book. And this is a problem because we'd like to collect or do analyses over entire collections. Let's say all of Shakespeare or all of Herman Melville, right? You don't want to be missing a book when you're doing an analysis. So gap filling is becoming one of our goals on that. Also, it could very well be the case that the library never collected the book, that the Harvard or Michigan or Illinois never bought that book in the first place. So it was not there to get scanned. And so we do a lot of work with experts, these scholars, to identify what we do have and what we're missing. And we call that gap filling, and that's one of the goals of this project. And we use many different tools. We'll use topic modeling, sentiment analysis, AI, to see if we can find these books buried in our collection. And so now we're showing some of the results. So this is that word gap filling. So you can see the green is that we found it in our collection. And we have bibliographies, lists of books that we know exist. And the purple, the pink color, are the copies that we know are not in the digital library. So we need to come up with a mechanism to work with the libraries, to work with scholars, to get copies into the HathiTrust. And that is one of the goals of the project. Yes, and so here's some example on the Native American. not very well collected by the libraries, even though the books might exist. And so we worked with these scholars to help identify what is missing and what we could ask to get included. So why did they want to collect this data? The scholar wants to find out what the sentiment analysis is a very popular kind of analysis done on texts. Want to know whether the notion of settler was mentioned in a positive light or in a negative light. Settler is now a contentious word in North America. And pioneer is also, they were studying that for their scholarship. And so you can see the results there. So the word pioneer is mostly used in a positive context, and settler is mostly used in a negative context. So we worked with a group of scholars that are studying Black science fiction, and it's called The Black Fantastic. It's a really, really kind of cool. These are books I never knew existed. And so they're trying to do the classic kinds of analysis that we do in digital humanities. Another term for this literature is Afrofuturism. So we need to find ways on whether we actually have it or don't have it. And what makes up these texts? What identifies a book as being a Black fantastic book, or maybe some other kind of science fiction, right? So they've been doing word frequency analyses. One of the key findings is that the words about time have a special place in this literature, and that's a finding that the scholar will go on and publish. So we tried topic modeling, didn't quite work as well. Term analyses, again, helped us uncover this time. But we're going to move on and we're going to try some better classifiers, more sophisticated machine learning AI classifiers. So this is a perfect example of one of the lessons I like to say all the time. Digital humanities and data science are becoming the same thing. I'm going to say this over and over. Digital humanities and data science are becoming the same thing. Okay, so we're going to use machine learning. So the Black Fantastic Project, as I said before, working with these scholars, Dr. Calissa West White and Saritha Williams. And can we use machine learning to find this genre, this class, and also to find more nonfiction English language books. So we used, so you have English fiction, you have Black authored fiction, and then you have the intersection of Black fantastic sitting in that nesting there. So we looked at support vector machines, random forests, logistic regression, and stochastic gradient descent. There's some statistic there. You can see some of the size. Not very big data sets because it's not a very big literature. And so SVMs appeared to work best at finding new ones and identifying them correctly. So we now have a tool to see if there are hidden Black fantastic books in a collection. We have a very small training set. That's one of the problems, is that the training set that we had was on the small side. And then we also took a look at the different topic modeling. There you can see some of the key terms there. And then another challenge is we have digital humanities folks that are looking for fiction. The problem with fiction in university libraries, as many of you might know, working in a university library, is that fiction wasn't classified as anything until very recently. So a lot of the fiction is not even classified as fiction in the catalog records. So you can't just go, give me fiction, and out you go. We need to find it. So we're going to use machine learning to study what fiction looks like, build a model of fiction, and then use that to uncover fiction books in the collection. So here's some cataloging records. These are all fiction. There's nothing in there that tells you that it's fiction. And the issue at hand is that when we built our first English language fiction collection, the collection has grown. There's about 1.5, 2 million more books in the collection than before. So now we have to go and not hire a bunch of grad students, which is how they did the first time. We want to see if we can get a machine to do it for us to identify works of fiction. So we did all the classic random sampling and built different models. I'm not going to bore you with the details. They looked at logistic regression, support vector machines, and random forests, very popular. And of course, one of the tools that's very popular in my community is Python as the data science toolkit, scikit-learn, and Python notebooks. Everyone we use a lot of Python notebooks. As you can see here, the logistic regression worked pretty well and support vector machines and random forest with, I believe, the best overall coming in with the, what was it? Support vector machine? I have to read the slide. I've lost track. Some interesting findings. There is places where our ground truth was wrong. So somebody cataloged a book about the American Civil War, very famous book called The Red Badge of Courage, as nonfiction. It's a novel. It's absolutely fiction. So it got into our training data set, right, as incorrectly labeled. So that doesn't help. There's this weird category of writing, memoirs, biographies, and travel stories use the very same language as novels. So the machine can't quite figure out, is this a travel story, or is this the novel about people going off to strange lands and so on? And it uses very similar language. So that was one of the classic issues. And there's also non-prose fiction, poetry, and so on. And then, of course, there are other errors. When you get works talking about fiction, but those works are nonfiction because they're talking about fiction, and those get mixed up. Okay, we're getting close, and I'm sure everyone's getting ready for their coffee break, so we'll get there. So we have this instructed features data set. It is very big. It's 17 million volumes, 2 trillion tokens. We were fortunate enough to get a grant from the National Endowment for the Humanities to make that collection, that big collection, more useful. Because right now, the students or so on, you can rsync, which is just a way of extracting large collections of data from a server, and you can put it on your laptop and try and do things. We got a grant to build an API to this collection. And if you don't know what an API is, it's just a mechanism through the internet to grab individual pieces of data. It's called an application programming interface. And this way, if we set up the data as an API, people can do and grab small portions of the data, maybe just the fiction. I just want the fiction features, and I'm going to do my student project, or I'm going to do my thesis on that, or I'm just going to grab only the German philosophy words and do whatever analysis is. And so this speaks to a couple things. One is that we need to stand up the infrastructure to allow the access into this API, into this service, and we need to help people build tools to use it, to build widgets, as we call them, that might use this data. And that's what the grant is about, us building out the infrastructure, and then teaching people how to use it, and then teaching people how to build widgets. And if a person builds a widget that we like, we will host it. We'll put it on our service, and that means other people can press buttons and do analyses and get interesting findings from the data. So we're working with a company to help us design the API, some professional programmers, and then we're having a conference next spring where we're inviting students and scholars and programmers to have a hack fest, where, come on, let's build data science tools and hit this, and we'll keep some, and we'll be pizza and good times for all. And that's going to be in Champaign next year. Okay, we have collaborations with many other universities and scholars. This particular gentleman is Professor David Bayman, who teaches at the School of Information Sciences at UC Berkeley in California. He is really, really smart. And he's created a tool called Book NLP. So it's Book Natural Language Processing. Turns out, I didn't really know this, David Bayman taught me this, most NLP tools are designed for shorter texts, with the text being, think of an article, think of a journal size article or paragraph size, right? Twitter feeds and things like that. Many of our NLP tools are designed around that. He has designed a tool that considers the whole book and book-like things in the analyses. So his project, and you can download his code, it's called Book NLP. And it goes through and it finds all kinds of interesting facts. So named entity extraction and so on, very standard, but will also track the use of pronouns. So Stephen Downie says, University of Illinois is great. He said it is also very boring. So Book NLP will track that Stephen Downie and he are the same person. And so, and I don't think University of Illinois is very boring. It's, thank you. There we go. It's very good. Very fun. Not as fun as Shimbishi, but very fun. Okay, so you can see there the different kinds of things that Book NLP does. What we have done is that we have taken, in collaboration with Professor Bayman, we have run Book NLP on Professor Underwood's fiction set, and we released it last week. So that's the big announcement. We have released a new free data set that anyone can have. It's 200, right? There's 201,000 books represented. It's in 600,000 files. It's about 500 gigabytes of data. And we did have to take out the quotation. So there is a quotation data type that he has in this collection, and it's a bit naive. It finds the opening quotation mark, and it finds the closing quotation mark, and then says, this is a quotation. When you have OCR errors, you might have the opening quotation mark and nothing at the other end, or you just might randomly have two quotation marks because of OCR errors. Entire books were being put into the quotation file. So we had to say, we can't share that. But we had to do analyses and experiments with that. So anyway, it's there. You can have it with your students, build projects with it. And we're very excited to do this. And this is another example of our main data set having data set babies, creating new data that we have to manage and curate and share. So we're at a very good time. Excuse me, I'm allergic to my coffee. My nose is running. Okay, so we have a problem at the HathiTrust. It's a challenge, and the challenge is scale. When things are this big, it's hard to deal with 800 terabytes of data consistently. So scale is always an issue. We have discovered that you need a combination of human expertise, so expert in a literature or an expert in digital humanities, an expert in data science, right? That come together and then bring these things together and use AI and machine learning tools to deal with the scale. So what do we do these for? To discover holes in our collection so we can fix them. Those are gaps. To build sub-collections that we call work sets that scholars will use to publish papers and so on, to do PhD theses, to do homework. We would like students to use this collection more for their term projects, and so on. To correct the metadata, we are discovering the human created metadata has many problems, and we'd like to correct that. To extract interesting features from the collections and share those features. Overcoming the OCR errors, so the collection is more valuable. Identify copyright issues. Can we discover books that are in open so we can release them and let people read them? Or do we find books that we have made open that are actually letting out copyright problems? And we want to be on the right side of the law, analyze the data, of course, and then curate and disseminate the results of those analyses, right? So it's a never-ending chain of growth, right? We have the raw data, scholars come and create sub-collections. We want to curate those. Those sub-collections generate results, which we need to curate and do research data management, and so on, and so on, and so on. And that's it. How's that for perfect timing? Thank you. Arigato. Clap, clap, clap.
Yes, thank you, Stephen. It's perfect timing.
So from the floor or from our online audience, we would like to receive some questions. Yes, go ahead, please.
Yes, thank you for a great work and a very interesting talk. And my simple question is that did you keep the scanned images at your side or you already discarded them?
Oh, okay. Yes. So the collection at Michigan, the 790 terabytes, it's about a 9-to-1 ratio. So the OCR is about 100 terabytes. That's all right. And the rest is the page images. So yeah, of that 800 terabytes, about 700 of it is images and 100 is text. Text compresses a lot. So yeah. We mostly just work with the OCR at this point.
Thank you very much. And then we have received a number of questions in chat. So they are in English. So let me start with the first question.
With the promise of the LLM, that is the ChatGPT and others, can we see ones focusing on the scientific literature, something like a sci art?
Yes. Yeah, so we did some experiments with SciBert. That was the OCR project with my PhD student, Ming Zhang. Yes, we are looking at some of those things. We'd like to get more scientists involved also. So one of our big goals, thank you, Arigato. One of our really big goals at some point is to build a large language model of our own, right? Wouldn't that be amazing if we could do it? Of course, would take a lot of resources and so on, and lots of hoops to jump through. But we have had and we have fine-tuned some pre-existing models to look for cause and effect and relationships in scientific literatures and so on. So yeah, we are thinking of it. We're just trying to find ways of making it possible. That's the best way. It's the future. I mean, LLMs and chat GPT-X is the future of this world. So we need to work in this space. Okay.
Okay, second one from the same person. Can I use your text mining tools and how to get access to copyrighted materials?
Yes. So here's one geopolitical issue. Everyone has access to extracted features. Everyone. Everyone has access to the book NLP data that we generate and so on. That's open. At this point, for the copyrighted materials, it's restricted to people that are members of member libraries, right? So if you're at the University of Michigan, then you would have access to the in copyright. I suspect then the people at Keio University would have access to the in copyright because they are members. At this point, If you're not a member, you can have access to the public domain. So you can get access to a data capsule and work on the public domain. There are other mechanisms, like if we're working on a collaborative research project, then that changes. But the HathiTrust reserves as a reason for being a member is that access to the in copyright data. Does that? I'm sorry, it's probably a disappointing answer, but that's the situation as it stands now.
Okay, the last question is what about the academic journals? Any AI, ML project at your end?
Yeah, so we tend, if I'm understanding the question correctly, we do like the word embeddings. We're looking at word embeddings and working with scholars like Benjamin Schmidt, formerly of NYU, who's now off on working on a startup. He's very interested in sparse representations, representations that can put the whole collection in your browser. Think about that. 17 million volumes in some form in your web browser. And he's working towards it. Large language models that fit into your web browser. That's another set of experiments. So we're working on that. We at the research center tend to be more applied in that there are other people building word embeddings and so on. And our work really is, can we use them to make our tools better, to make our scholarship better for people? We tend to be much more on the applied side. And does OCR actually affect SciBERT? And as I said, not that much, right? So that's more or less our AI ML work, more on the application, the empirical evaluation of those systems against our data, if that makes any sense. Does that answer the question?
So now it's time. So I think we can end this part of the presentation. Thank you very much.